Welcome to video 9.10d, trigonometry with angle of elevation and depression. Let's first define those terms. Angle of elevation, I like to say out and up. What I simply mean by that is you go straight out horizontally and then up, and that is the angle of elevation. Angle of depression, I like to say out and down. You go straight out horizontally and then downwards, and that is the angle of depression. One thing to note, for two observers, one's angle of elevation is congruent to the other's angle of depression. So let's say I've got a person sitting at point A and point B. Notice I've got two horizontal lines. This angle of depression straight out and then down. This angle of elevation straight out and then up. So what I've got is alternate interior angles, and if lines are parallel, then alternate interior angles are congruent. So just keep that in mind. The angle of depression is congruent to the angle of elevation. All right, so I've got two examples here. Example 4. And one note, these drawings are not to scale, and normally in class I'd have a student draw these because I am really bad at drawing. All right, so you are on a cliff 360 meters above sea level and spot a ship at a 28-degree angle of depression. What is the horizontal distance to the ship? So first thing we're going to do is draw the line of sight. And I usually make my drawing so the person's laying down, so we have to figure out about their height. All right, now angle of depression, again, out and then down. 50% of the mistakes are students just label it right there. So I always want you to dash out and then go down and call that 28 degrees. And then if you want, you can put 28 degrees there. For trigonometry, I care about angles inside the triangles. So I'm going to put 28 degrees right there and have this be my right triangle. All right, I want to find this value here. I'll just call it x. I'll circle my reference angle and I'll label. So you would be the hypotenuse. This is 360. This is opposite. And this would be the adjacent. All right, so now if I know the angle, I'm going to use regular trigonometry. Okay, so a side I know and a side I'm looking for. So I'm looking for a function that's got an O and an A. Once again, I'll write down SOHCAHTOA. An O and an A, that's going to be the tangent function. So my equation will be the tangent of 28 degrees equals 360 over x. Then I'll just solve that equation. I'll multiply it through by x. So x times the tangent of 28 degrees equals 360. And I'll just divide each side by the tangent of 28. So x equals 360 divided by the tangent of 28 degrees. So let me punch that out. 360 divided by the tangent of 28 degrees. And I get 677.1. 677.1 meters. I didn't say how to round, but in general I'll just go to one decimal place. Okay, example 5. A plane is 7,200 feet in the air directly above your house. You are lying on the ground 50 feet from your house. What is the angle of elevation to the plane? Okay, so again, we're going to draw a line of sight and construct a right triangle. Let's label what we know. We know that this is 7,200 here. We know this is 4850 here. Again, not drawn to scale. And we're trying to find the angle of elevation out and then up. Out and then up. So I'm trying to find that angle theta right there. All right, so theta is my reference angle. I'll start labeling. Again, you're the hypotenuse, you're the opposite, you're the adjacent. So once again, opposite and adjacent, tangent from TOA. So I'll write my equation. The tangent of angle theta equals the opposite
7200 over the adjacent 4850.
What undoes tangenting? Inverse tangenting. So theta
Will be the tangent inverse of 7200 over 4850.
I'll just put that in my calculator. Second tangent inverse, 7200 divided by 4850. And I get about 56.0 degrees.
So theta is about 56.0 degrees.
Again, I round the nearest tenth unless otherwise specified. So there you have it. Angle of elevation, angle of depression used with trigonometry.